That's right, not negative 4x equals 20. We should not refer to this. But before we get into this, let's talk about, again, I'm not saying get rid of negative at all. So let's first get into when you should use negative. Hey, so I'm not going crazy here. What are the good uses of negatives? That is when you know the value of the number. So some of those are -8, the classic, -1/2. Again, fractions, absolutely negative. -3 pi. So this is an irrational number, absolutely still use negative. And again, -5i, even imaginary numbers. Again, a lot of numbers, we know the value, you can use negative. So what this whole video is going to be about is when is there should be a different view of when you see this negative sign. Again, you can't always think negative. Again, most of the time, and again, I just showed you when you should think of negative, but in this case, it's when you do not know the value. So when does this occur? When you do not know the value of a number, that is by definition any variable. When it's any variable, you should be thinking something different than negative. And so here we have all those other numbers, but with variables in this case, you should be thinking something different, and that's what this video is going to be about. But first, let me introduce myself. I'm Mr. Slangren, Mr. S. My day job is an 8th grade math teacher, and here on this math channel, we pursue that aha moment and celebrate with the big math rocks. Again, I'm in the library, so I want to be kind of quiet, because I believe the more you understand that the less time you're going to have to be spending those times practicing, because nobody likes to practice, right? So if you understand more, you can practice less. So let's make it click so it'll stick for a true understanding of, and again, I'm not going to be saying this much, -4x. But first, song. Let's hit the song.
I want to win. Yes. Math rocks. Don't listen to the haters. Math rocks. Let's put the work in now. Math rocks. Math rocks. Math rocks.
All right, so these 3 reasons are going to go from the least mathematical to the most mathematical of, again, why we do not say -4x. So to help understand this first positive and negative relationships, we're going to look at 3 real-world examples to help us understand this positive-negative relationship, and we will be seeing this number line a lot. You can see the blue side is positive, the red side is negative. All right, so you can see I'm a little small dot here because we're going to be using a lot of room here for this real-life example. So the first one is going to be seasons of the year. So on our far right, our positive side, because we like positive, summer is heat, right? Heat. But then what's the opposite of that is winter, right? That's where it's cold. And you can see cold is the opposite of heat. So we're trying to use that real life example between positives and negatives, right? Positives is really hot. Cold is really negative. Okay, so where is in the middle? Where is the middle between these two dichotomies, right? So where's in the middle between positive 15 and negative 15 is 0. Well, in this case for the season, spring and fall kind of go in there. So let's just start off on spring, March 20th. That's the middlemost spring day here in the middle. And when we add from spring, so when you go March to April and May, when you add those days, you're getting closer and closer until obviously you hit summer. And now where is that summer high point at? That's called the solstice. So the math people have already done this. And once we are in that positive thing, after June 21st, now the sunlight goes back down. We are subtracting. So you can see we're subtracting, but we're still in summer. But now when we get back to the middle, quote unquote middle, again, I know this is not perfect. It's not totally 0 here. But 0, we're just going to be defining it here as just the middle point between the positive and negative side. We're going to be going into fall. But now when we subtract, now we're in the negative part. Now we're getting closer and closer to winter, all right, which is the opposite of summer. Until we get there, and that benchmark solstice is December 21st, and that's where it's most dark. And what you really want to understand is there's a big difference between positive 15 and a big difference between negative 15. There's a big difference when you're adding days from spring to summer, when you're subtracting days from summer to fall, but then when you're subtracting from fall to winter, that's a lot different, right? Because now you're subtracting, we're getting more and more negative, okay? And before, when we were subtracting in summer, we were actually staying positive, right? Because it's still hot out for summer and into fall. But once you go from fall to winter, that's when it starts getting that cold, that negative temperature. And then what happens at the end? Well, December 21st, we have January, February. That is also still warm, right? Not still warm, still cold, all right? And so when you're adding in that negative, you're getting less and less negative until here we are right back in spring. So you can see the cyclical manner of this. And so let's go into the other 2 examples. All right, so this one is going to be actually just one day. Now we did the seasons. Now we're going to make this a little bit smaller and just go into days. And this time I'm going to use my laser pointer for help. This time we're going to go day and night. All right, so day is the highest temperature, night is the least temperature. And so our middle is the horizon, right? When that sun is in that 50-50 spot, we're going to start off at, and we'll use my little laser pointer, 6 a.m. So when we add, so this is 6, 7, 8, 9, 10, 11, but when we hit that zenith, the zenith is the most of the day. That's between 12 and 1 p.m. Now we start subtracting for the sun starting to go down, right? from 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m. until we're at 6 p.m. Now again, we're back in the horizon, but now the sun is not going up, the sun is going down. And so there is no sun now when you get to this subtract point, right? So that's 8, 9, 10, 11, and we're getting midnight is back to 12 a.m. That's called nadir. And that's when it's going to be the coldest. And then again, we're going to add at 1 a.m., 2 a.m., 3 a.m. Again, there is no sun, but the sun is getting closer and closer until you can see, again, we're at that big horizon. But again, we're really trying to take this home of there's a difference between positives and negatives, right? This is where you see the most sun. This is when you see the most dark, okay? This is when it's going to be the least temperature. This is when it's going to be the most temperature. And again, the difference of subtraction, right? When we subtract here from 1 p.m. to 6 p.m., it's still positive. The sun is still out. But when we subtract over here from 6 p.m. to 12 a.m., all right, in this case, there is no sun, right? We're getting less and less sun. There actually is no sun. And here, when we're adding, all right, there is actually no sun. Even though you can't see it, it's getting closer and closer. It's getting less negative, all right? Again, this is the hardest part people don't understand is about subtracting and adding on this side of the number line because we don't do it very often, right? We're used to adding this part. So let's go into the next one. All right, in this example, we're just going to show that, hey, this works for other things too. And again, maybe think of one for yourself. In this case, we're going to talk about boiling the states of matter. All right, so boiling, this is H2O water. So boiling water and freezing water, right? So what's in the middle is the liquid. So we're going to say 0 is the liquid. But again, we're just saying that's the middle value, right? Again, there's not technically 0, right? Liquid is 32 degrees to 212 degrees. But as we're in this middle part, right? So this is, we're going to say 122 is right in the middle. All right, so this is when water is in liquid form. Now when we start adding, all right, we're going to start adding until we get to this 212, then it's going to be gas. All right, that's when it's going to start boiling, turn water into gas. Okay, then if we turn off the temperature or turn it down, now we're going to start subtracting. Once it hits that 212, then it's going to start going back down into a liquid. It'll still be warm, right? And again, you can still burn yourself, but it's going to be a liquid. Now once we go past this 122, now it's actually going to be closer and closer to being a solid. All right, now it has to get to below 32 degrees before that happens, but then it's going to be a solid. And then again, if you warm it back up, like if you take an ice cube and you put it, just put it out, it's going to start adding, right? And it's going to start melting back to that liquid form. So again, we see this cyclical manner. But what do I like this is, again, you see there's a big difference between gas, right, where you're boiling the water, between the solid of liquid, which is ice. There's a big difference, and again, you've got to understand that difference. There's a big difference when you add and subtract when you're getting closer from between gas and water, whereas it's different when you're adding and subtracting when you're getting into the solids. All right, so the last real life negative context we have. So again, not in these real world examples number line allows us to go to context. So bad context, a score of a test, right? If you get a lot of negative scores, right, that's not good. All right, debt, money woe. Ooh, we don't like that one, especially me. Adults, talk to your parents about that one. All right, good. Golf score. So there are some good negative connotations there, right? You want to score -20. Tiger Woods, right? -20, -25. You want to do that. And again, blood results. So the negative score is good, right? Depending on, most of the time you want a negative test result. So what are the context with -4? We really want to go back to this math now. -4 has a big different context between -4x, right? That variable, that unknown value, when you put that negative symbol in there, we're going to do that. So what is this going to be? Let's get into it right now. All right, so let's Google it. Definition of a negative variable. So we're going to see this big definition, and again, you can see the other part I highlighted if you want to pause and read this. Again, the best part I like is this one. The variable itself isn't negative, and that's why I don't like to use negative, because you necessarily here. So if you scroll down here, Khan Academy, I think, gives the best answer here, is that it's the opposite of that number. All right, so from here on out, we're not going to refer to this as -4x equals 20. Drum roll, please. It is going to be the opposite of 4x equals 20. And so let's get into more of that. So using these three examples, so what we saw, these are opposites of each other. And that's what you really need to see is we got to see which side are we on? Are we on the summer side or the winter side? Are we on the day side or the night side? Are we on the boiling side or are we on the freezing side? You see that the positive and negatives are opposites of each other. We need to know which side are we on when we're dealing with these variables. So our first reason was real life relationships with negative being the opposite. All right, so we just went through these. First one. All right, our second one's going to be more mathematical, and this one's going to focus on a different type of number, different rules. Let's get into it. All right, to get it back to this, we need to go back all the way from first to fourth grade. So what do we do in first to fourth grade? Add and subtract. But a big difference is we couldn't do 5 minus 8, right? I was really traumatized as a kid, like 5 minus 8, oh, you can't do it. But then when we got later, it was like, why can't we do it now? Right, and then also multiply and divide. But the big thing with dividing, or again, multiplying, you couldn't do decimals, but dividing, you could not get, all you had to do is stop at a remainder. All right, so the first 4 years, we just concentrated on that. And fifth and sixth, again, we even get less time too, right? So 4 years to do all those things. Now we only get 2 years to do these. Now we have to do all those operations, but now we have fractions. And again, I just say fractions, but fractions and decimals. So there's more steps. You have to simplify fractions. And again, see those steps. And then also no more remainders, so we get decimals on that. So we also can multiply decimals. So we're doing all these with decimals and fractions, the same 4 operations, but all decimals, fractions. Which again, really fractions, because decimals are just a fraction. All right, now we just get 1 year. So we had 4 years to do, those operations, add, subtract, multiply, divide. Then we had 2 years, just 5th and 6th grade, to do it all with fractions. In 1 year, what do you have to do? You have to do all those things now with negatives. So again, we're doing harder things with less time. So obviously this is why some students start to struggle, right? So now we can take that 3 minus 8 and say, hey, it's negative 5. But then also, we're going to not just always start on the positive side, the blue side. We're also going to be on the red side, right? So starting at that side, negative 3 minus 8 is negative 11. So we are going to add and subtract, multiply, and divide on all sides of the number line. All right, so to review, again, only positives for those first 4 years. 2 years, now we're going to be getting all positives, but now it's fractions and decimals. In 7th grade, now we're doing everything, but we're also doing it with negatives, so it makes it harder. So why we have to review all that is now we're doing something different in 8th grade. All right, so what is different for 8th grade is you have to do rational numbers, so that's all in 7th grade, but now we're including variables. So now you have to do these operations with a variable, a different type of number. Just like fractions were different numbers, variables are different numbers with different rules. And again, we're not going to go through all these rules, but just as examples of, hey, these are different things, right? You can't do 2x plus 8, right? It's not 10x, right? You can't add them, but you can multiply and divide them, right? So again, just showing that there's different rules. Just like with adding and subtracting fractions and all those, there was different rules. There's different rules with variables. So you can't take 2x times 8 and get 16x. And again, you see this different dichotomy here when you do have similar, like terms. So 4x plus 2x is 6x when you both have variables, but when you multiply those, it's 8x squared, right? Whereas before, you just keep the x when you're adding. When you're multiplying, the x actually increases in the exponent as well. So you can see there's tons and tons of different rules with these variables that you have to do in 8th grade. So different rules with variables. Just like there's different rules with fractions, there's different rules with variables, and that's key. So with this, again, different rules for adding, subtracting integers, all these different rules like multiplying decimals, dividing by decimals, there's different rules. So there's different rules with variables. So we're not thinking of this as, we're thinking of this as not, we're saying this is the opposite of 4x, not as negative, okay? So that's the big thing. Think is negative is, again, I'm already kind of even saying here, it's the opposite of 4x, not that, right? That word, right? It's the opposite of 4x. Because if x is positive, let's say x is 2, then you actually multiply by a negative, the answer is negative. But if x is negative, when you multiply by another negative, the actual value actually is positive. So the second one, again, I know this is very, very tough on here, but the opposite of 4x could be positive or negative, just depending on what the value of x is. And again, what is a variable? A variable is an unknown number, right? Sometimes it's one specific example like it is in this problem, or it's any number, right? And so since it's any number, you don't actually know whether x is positive or negative. That's why let's go through solving these equations. In this case, the opposite of 4x is positive, so that means positive 4x is actually negative. And we're going to go in this more in detail showing this, right? So here, the opposite of 4x, where x is actually negative, but if it was something on the other side, on this side, we take the opposite of here, x actually is positive. So you can see both started off with the opposite of 4x, but we got different answers. One is positive, one is negative. All right, so the first reason was those opposite relationships, right? Summer and winter, noon and midnight, right? There's opposites. Positive and negatives are opposites of each other. The second one was, again, different rules for different variables. So we have fractions, we have decimals, we have all these rules for different numbers. When we have a variable is a different number, we have to have different rules. So when we see this negative sign, in this case with a variable, we're not thinking negative, actually, we're thinking opposite, because again, you have to think of something different for different numbers. All right, our last reason is most mathematical. This is gonna be so fun. Let's go. All right, so let's use a number line on here. 8 is greater than 6. So that statement is kind of obvious, right? But why is it? Let's look at a number line. You can see 8 is further to the right than 6. So that's 8 is greater than 6. But if we look at -8 and -6 on the number line, we see that -6 is actually further right. And so -8 is actually not greater than -6. -8 is less than -6. And if you actually want to see which one is greater, it was actually -6 is greater than -8. All right, let's look at another opposite, all right? 10 plus 4, all right? 10 plus 4 is more value, it's 14. But if we take -10 plus -4, now we're at -14. This actually has less value. When you add two positives together, you get more value. But when you add two negatives together, you get less value, which is opposite, opposite, opposite. So you can see opposite sides of positive and negative, opposite things happen. All right, so hey, it's Mr. S. Look at this top right now. We're going to do some really fun special effects here. Hopefully it'll work. 4x equals 20. So you see right here, 4x is equal to 20. So you see they're on the same side on the number line. We're going to put the variables on the top side of the number line, the number on the bottom side, just so we can use this number line to help solve this equation. So if we go on this side, we're going to divide by 4 on both sides. So that's what that blue number is, divide by 4 on both sides. And so we get x equal, x equals 5. We made the value smaller, so here we see 1x is equal to 5, right? So we're using this number line, and this is going to help us explain why the next problem. All right, so here we go. Moo. All right, here. Now we're not at positive 4x, now we're at negative 4x. So let's see, I got to figure this part out. All right, this is the opposite of 4x, and I'm saying this right, is equal to 20. And we're going to get into more detail on this later, but how do we get rid of this opposite of 4x? Well, what's the opposite of 20 is negative 20, all right? So we can see we switch sides. So now this is not the opposite of 4x. This is now the real value of x, 4x, right? It's not actually positive, it is negative, right? So we see that negative down there. Now that we have the actual real value of x, now we can solve it. And so if you look back at the other side, you can see that divide by 4. So we'll move down here. Now we get x is -5. So we want to really see that big difference between these two problems, right? The first one up top, that was just all positive, right? So it stayed on the positive side. But the one below had the opposite of 4x. So what's the opposite? Well, you had to switch sides from the blue side, from the positive side to the negative side. And the actual value of x wasn't positive, it was negative. All right, so now I'm here in the top left corner. Let's do another problem. Again, we need to understand this. And again, that's why we're just doing a one-step equation. But hopefully you can understand that the mathematical reason of why this is the opposite. When you're dealing with variables, this is the only time you should really be thinking of opposite, not negative. All right, so now we have positive, I'm not positive because we're not on the positive side, but let's just say the real value of 4x is -20. So do we need to switch it to the other side? No, and again, this is what students all too often do is, right, they switch it again, but we shouldn't switch sides. If x is just by itself with no negative sign, we should just keep it on the same side. So we divide by 4, and here we go. We just like from the previous slide, it's just x, but x is not positive, it is negative. You stay on the same side. You only switch sides when it is the opposite. So let's move on down to another problem. And again, maybe I should put the equation over on the other side, but it's still on that side way over there. So -20, the opposite of 4x equals -20. Now this is where we have to switch sides. So here I am. You can see the opposite of 4x is -20, so the real value of 4x is +20. So you can see we switch sides. If you want to replay it back and look at the equations right up here, and see we switch sides. Now when we know the real value of 4x, now we can divide by 4 on both sides, and now we switch right over here to say x equals 5. So again, we can see on that top, we didn't have to switch. Okay, the bottom is where we had to switch. Why? Because it's the opposite. And that negative with the variable really changes the value a lot. You switch sides, which again, if you're looking at our real life world examples, that's a big thing, right? If you switch sides, that's a way big difference between night and day, summer and fall. That's a big difference. So a big mistake teachers make, including myself, for years and years, I made this mistake here, is saying this is just a one-step equation. But when the variable has that negative sign on it, I would say that's actually a two-step equation because you have to get the real value of x. You don't want the opposite value of x, you want the real value. So the opposite value of 4x is 20. So that means the real value of 4x is -20. And now that you have the real value of x, now you can divide by 4 and say, hey, this is x equals 5. This is actually a two-step equation in my book. And so this two-step equation actually turns into a multi-step equation. So again, subtracting 8, that's like a normal step. But now we say, hey, this is the opposite of 2x equals 20. So we need to know what the real value of x is, right? So the real value in this case of x is negative 20. And so x is negative 10. All right, so we are ending this here. So we had those two relationships. This last one is to solve for x, you have to think as the opposite, because you have to go to the opposite sides of the number line, right? So you switch sides when you solve an equation, and when you have a variable saying that it's negative, you actually switch sides to either positive negative or negative to positive. So visual review of what we just talked about. Positives are opposite of negatives, right? Summer is the opposite of winter. Day is the opposite of night. Boiling is the opposite of freezing, right? Positive and negative are opposites of each other. You really need to understand that opposite relationship between positive and negatives. All right, this one, we had, again, you see all these different rules for different numbers. 7th grade was adding and subtracting negatives. 5th and 6th grade were fractions and decimals. You have different rules to do those things as you move on, right? So when we talk about what is 8th grade were variables. So when you have variables, they have different rules, just like fractions have different rules to add fractions. 2 minus negative 7, right? Negative 2 minus 7, right? So grade 7, that was with negative values, they have different rules. Variables have different rules too. So this is the second reason. All right, and the most mathematical reason was solving these equations. When you have the opposite values, switch sides. So you see here the opposite of 4x, we were on this side. Now we're on the real value of x was actually on the negative side. And if you go to the bottom here, now that the opposite value is actually negative, but then we have to switch it over to being positive. If I can get my signals right here. On here, this is the most mathematical, right? You switch sides when you're solving for that variable. Again, take it as a step. Don't just do this all in one step with switch sides and divide by 4. You should really do this in 2 different steps so you don't get confused. You only switch sides when the variable is negative. Again, when a variable is opposite of each other, not negative. All right, so if you had some aha moments, please like this video, subscribe, and don't always forget to say, Math Rocks. Again, I'm in the library, can't be so loud. See you next time.